Welcome to this video. My name is Darshan KATGERI and I am working with Jain College of Engineering, Belgaum. In this video, we will be solving a problem on isometric projections. In that, we are going to solve a combination of solids uh, wherein we will be having three solids placed one on top of the other, and all of the axis of all of these solids will be in line, right? So we are going to solve this particular problem. So let us move on to the next slide and see what is the problem given and try to solve it. Now here I should mention that this orthographic view is given to us, right? So the problem reads like this: draw the isometric projection of combination of solids as shown in the figure below, right? So this solid should not be there, as shown in the figure below. So this figure will be given to us. This may be put in the form of a statement, like this figure will not be given sometimes, and all of this combination will be mentioned in the form of a statement, like a cylinder of diameter 50 mm is placed on a square prism of edges 70 mm and height 50 mm. You can see the height is 15 mm, sorry, 15 mm, and a cube is placed on top of the cylinder, right? And the dimensions of the cube are 30 mm. So the problem could be stated in the form of a statement, or this view will be given. So in this case, the view is given and we have been now asked to draw the isometric projections, right? So again, it is projection. So we should take note of this. So this combination, let me just show you the visualization. It appears, or it looks somewhat like this, right? Wherein we have a square prism here, and on top of the square prism we have a cylinder, and on top of the cylinder we have a cube. So if you see the top view of this, it will appear like this. So you can see that we can see this square here, which is nothing but this square, and the dimensions of this are 70 millimeters. And then you can see the circle. This circle is the cylinder. It is the cylinder. So this circle is the cylinder, and this square is the top view of this cube, right? So this square is the top view of this particular cube, and in the front view we can see like this. We can see the heights, right? So here the height is 15, and this is the height of the cylinder is 20 mm, and the cube is 30 mm. So we can see the heights in this front view. So this is the combination, and we have to now draw the isometric. We have to actually draw this. This is isometric, right? So we should draw how it looks in isometric projection, right? So let us move on and see how to go about this problem. As usual, to start with, we have to start by drawing a 30-degree line like this. So you have to select one point and you should draw one line in this particular direction, and it should be at 30 degrees, and another line in this particular direction, and that also should be at 30 degrees with respect to the horizontal. Now here I see that it is an square of 70 mm. So the next step is to mark this particular square. That is, you have to take isometric 70. That is, you should multiply this 70 by 0.81649, and whatever is the length, that has to be marked here. So let me just mark it here. So 70 into 0.816 I will measure, and from here I will mark an arc like this, and I will mark another arc on this side also, both because both of these lengths are same. And to obtain this point, I will draw one arc. From this point I will draw this arc, and from this point I will draw this particular arc, and I will join these lines. So I will get the square. the isometric view. Again, let me mention that whenever we are doing it in the software, we will draw the view first, and then all of the lengths will be converted to isometric lengths by multiplying all of them all together by a factor of 0.81649. So we can do that in software, but while we are doing it manually, we have to calculate each of these lengths and mark those lengths here on this particular view or isometric projection. So we can either use the multiplying factor, or we have to make use of the isometric scale. So I will be solving this problem in solid edge also after this explanation, so we can understand it better. Then again take isometric 15, that is multiply 15 by 0.81649 and draw these lines. These lines are at 90 degrees to this horizontal line, and to the end point of these lines now you can join all these points, and you can now get the top face of the prism like this. So once you do this, now you have to draw this cylinder. So to draw this cylinder, we have to somehow get this square, this particular square. So to get that square, what we can do is you can imagine that this cylinder is enclosed in a square like this. This cylinder is enclosed in a square like this. Say, for example, here like this, right? And like this, yes, and like this. So what we require is we require this particular square, this particular square here, right? So we have to know this particular distance. This particular distance needs to be known, and this distance will be equal, because this is the outer surface is a square, and inside we have a circle which is centrally placed, right? So this distance will be equal. So this distance also will be equal. So what we can do is we can mark arcs. So I'll just take a different color and just mark this. We can mark one arc here. We can mark one arc here. From this point, mark one arc here, mark one arc here. That is, we should actually measure this distance, convert it into isometric length, and from these particular points you should mark the arcs. Similarly, from this point we can mark these arcs here like this. So these arcs have to be marked, and then you have to join this. So once then when you join this, then we will get the square. That is, we are interested in this particular square, right? So this is how we need to obtain this square, and in this square we have to draw the cylinder. To draw the cylinder, you take the midpoint of this. You take the midpoint of this particular line, and you join it to this corner here, and this midpoint you join it to this corner, and the midpoint of this line you join it here, and the midpoint of this line also you can join it here. And then you can take this as the center. Let me take a different color. You can take this as the center and this as the radius, and you can draw this arc, and similarly this as the center, this as the radius, and draw this arc. This center and this radius, you can draw this arc, and this center and this radius, you can draw this particular arc. So we will get this a circle. So this is nothing but the four center method. Yes, so this is the square that we are interested, and the next step is to get the circle, and the procedure of which I have explained just now. and then the height is 20 millimeters. So from each of these corners you have to draw one line whose length will be equal to ISO 20. ISO 20 means 20 into 0.81649. So that should be the length of these lines, and then again you can join all of these points, and then on this face again you can repeat the procedure and draw the top face of the cylinder, and then you have to join these lines here. You have to join this particular line here and this particular line here, and that will be the cylinder. That will be the cylinder. You can see that this is the cylinder. And next, now on top of this surface we have to draw this square. So again we have to imagine that this is enclosed in a box. This is a box itself. So what we can do is again you can take the previous square which you have drawn for the circle as a reference, and with respect to this we can draw another square. With respect to this we can draw another square, say for example this square here, say like this, from here and from here. So we are interested in these distances, this particular distance here and this particular distance here. So those distances have to be obtained, right? So you can see that I can draw one arc here, whose length is equal to the isometric of this particular length, right? So this particular length has to be measured from here, and then you have to mark the isometric lengths here like this, and same should be done on this side also and on this side also. These are the arcs that I'm drawing, and you have to join the lines. You have to join the lines like this. We have to join the lines like this, and then this is the square that we are interested, right? And once we get this much, we have to just draw lines of 30 mm from each of these corners like this, and then join these lines so that we get this particular cube. Let us get rid of all the ink here. So this is the procedure of drawing this. Now I will show you how to do all of this in the software. We'll go to the software. So this is Solid Edge again. The first thing that we will do is we will go to sheet 1 and change the sheet. We will select A4 sheet, and we will turn off the background, otherwise all of this template will come, and we will save it as defaults and we'll say OK. And then you go to fit screen. Fit screen is this cross mark with arrows. You just press that particular button and it will fit here. Now one thing to note here is that I know all the dimensions that I require, right? So no need to draw this orthographic view, but however for completeness of the problem this view may be drawn. But in this particular case I am directly going to draw the solution, right? So I will select a line. I will change the thickness of the line, and I will draw one line like this, and I will draw one line. Now again it is important to note that I will be drawing the isometric view here, and then I will convert all of the lengths at once by multiplying by a factor of 0.816, that is by using the scale command. So the dimensions of this particular line that I will be drawing is 70 millimeters, right? So the dimension will be 70 millimeters, and the angle of this line will be 30. So now you can see that this line is 70 and this is 30 degrees. Similarly, I need one more line that is starting from this point. The length of this line is also 70, and angle in this case will be 150 degrees. So let us show the angles. So I will zoom in. So this angle has to be 30 degrees and this angle also has to be 30 degrees. So now once we have done this, I will select these two lines and I will go to mirror option. This is the mirror option. I will select this and I will select the axis about which it is going to mirror. So I want to mirror about this particular dotted line, and I have now selected that particular line and it will mirror this like this. Next step is to draw the height. The height is 15 mm. Again, I am drawing the view, so I will be drawing it to actual lengths only, and then finally I will be converting it. So this line that I will be drawing is 15 millimeter and it will be at 90 degrees, and I will select this line and I will move it to these particular points. I have to switch on, that is activate this copy command, and then it will go on creating copies for us. In this case, I need 4 copies. The last one was not placed properly, so I will place it properly. That is from this point to this point. Use the inference symbols correctly, and then we can move all of this at once from this point to this point, and now the square prism is ready for us. Now in manual drawing we have to construct the square here, get the square here, and draw the cylinder. But when we are doing it in the software, what we can do is we can construct it outside and then align it such that all the axes are in line. So that is what we will be doing in this case. So the cylinder is 50 millimeters in diameter. This 550 means it is the diameter. If R50 is given, then the radius will be 50 mm, but in this case the diameter, the complete length is 50 millimeters. So now we have to construct one more square. I will be constructing this here. The length of this is 50 millimeters. So the length of the line that I will be drawing is 50 millimeters here, and this will be at 30 degrees. Yes, we have to press enter, and yes, you can see that this line is 50 and it is at 30 degrees. Similarly, I will draw one more line of 50 millimeters and 150 degree angle, right? So once we are done with this, again we can select the mirror command and mirror it about this particular line. And in this I am going to construct the cylinder. So I will be selecting a line and I will be joining the midpoint of this to this corner, and this corner to the midpoint of this line, and same on this side also, like this. So once this much is done, then we can go for arc by center point, and we can select this as the center and this much as the radius, and we can draw the arc here like this, and this as the center and this as the radius, and we can draw this arc like this, and this as the center and this as the radius. One arc can be drawn like this. This as the center, this as the radius. This arc can be drawn like this. So once this much is done, we can spot the center by joining these lines like this here, and by joining this line like this here. And the height of this cylinder is 20 millimeters. So what I will do is I will draw one line 20 millimeters from here. This 20 millimeters, and it should be 90 degrees. and I will select all of this. I will select all of this. This line is also selected, so I will deselect this. I will press Ctrl and click on this line. It will be deselected, and I will use move command with copy on, and I will move it from this point to this point, right? So we see that the top surface is very easily created. It is a matter of just moving it from this point to this point. However, this facility is not available when we are doing manually. So there has to be a lot of construction that has to be done in manual drawing. Finally, I will select a line, and in this case I will be joining tangentially, or it is same as joining the centers in this case. So you can see this point I will take and I will join it tangentially like this. So once we get this much, then we can darken whatever lines are required. So before that, we can split wherever required. We have to split at, say, this particular point, and this arc at, say, this particular point, and we will select the arc. So this is these are the arcs that we want. So we will select all these arcs, and then we will change the thickness of the line. We will make it 0.5. So this is the cylinder that we are interested in. This cylinder has to be placed at the center of this. So first we have to mark the center of this. So let's mark the center of this by joining these two lines here like this. So wherever they intersect, that will be the center, and the center of this is this point here. This point, as you can see, this is the center of that is, this point has to be moved to this point, and we are going to do that now. I will select all of this, and I will go to move command, and I will keep the copy. So once I move it, I can delete this. So I will move it from this point, and I will say pan and to this particular point. You can see that the inference symbol has come like this. So once I am satisfied with this, then I can delete this or put it on a different layer. So let's try to make a block. Yeah, we will make a group out of this. Say OK, and then I will come back here, select all of this, and you can say cut at once. I have to do all this because the delete button on my laptop is not working properly. Okay, let's move on. Next, I need a cube, right? And the dimensions of the cube are 30 mm. So let's go ahead and do that. So I will select one line, and I will draw one line. The length of this line is 30 mm, and the angle is 30 degrees. Similarly, on this side, the length is 30 and the angle is 150 degrees. And then we will select all of this and mirror it from here to here. That is about this horizontal line. And draw one line. The length of this line will be 30, and the length, angle will be 90 degrees. And then we can select this, make copies of this line from this point to this point to this point to this. It's not placed properly. So let me undo once and draw one line from this 30 and angle is 90. So once we have done all these lines, select this, deselect this, and move it from this point to this point, and now we are done with the cube. So let me darken whatever will be visible. So all of these lines will be visible. So let's make it 0.5. and now it has to be placed at the center. Now we can see that the center is here, so this particular line here and this particular line, they intersect at this point, and this cube has to be moved to that particular point. So for that we have to spot the center of this also. So you spot the center of this, and then this will be the center point. The center point of this line will be the center point, or else you can go ahead and join this point and this point. So wherever it intersects, that will be the center. So you select all of this and you go to move command and you select this midpoint, and now it has to be moved to this particular point here, this particular point here. And let me zoom out. Yes, and this again we can delete this. I will group it and then I will delete it. So this is the isometric view. What we have done is we have drawn the isometric view. So we have to do a lot of work here. So first we will save the drawing, and I will save it as isometric projection combination of solids. This is the second problem on combination of solids, and I will save it. Next, once it is saved, now I see that I have to split few lines. So I will go to split command and I will select this line, and I will split it at this particular point here, this point here. If it is not working, then you try to turn off some points. That is, I will turn off midpoint, deactivate midpoint rather. Let's try it once again. Split this line at this particular point. Yes, now it is working. And no, sorry, that was not right. What we have to do is we have to split it at this point, not this point, but this particular point. So we will redo that. Select this line, and I want to split it at this point, at this point, at this point. Similarly on this side, I want to split this line. This line is nothing but this line of the square prism, and I wanted to split it at this particular point. So these are the two lines which I want to split. So once I split the lines, I will select all these lines. I will select all these lines, and we will change the thickness of these lines, and we'll make it 0.5. So now you can see that whatever is 0.5 thickness is the drawing, that is the isometric view. This is the isometric view. Now after doing all of this, I have to select this, and this is the most important step. That is, you have to multiply this by a factor. So you go to scale, and the multiplying factor is 0.81649, and I don't want a copy of this, so I have not put on the copy, and I will keep it here. So this is the complete solution. Okay. However, for clarity, what we can do is we can create layers. Say for example, I will create one layer, and I will say construction, and I will put all the lines that are not required. So this particular box here which we have created, So this box, that is these lines, we will select all these lines. So it will take 1 or 2 minutes. So I am selecting all the lines, and the part that is not visible, so we have to be a little careful while we do all this. I hope I have selected all the lines, and then I will move all these lines into this particular layer, and I will say OK, and then I will try to hide this particular layer. Yes, so you can see that we have left out few lines. We can again go and select these lines. So this one, and this arc here, and these lines, this line and this line. We can again go back and move the construction elements into this particular, yeah. So this line also we can put in the layer. Now I see that we have somehow left out this particular part. So I will come back here. I will come back to sketching. I will select split command. I will select this arc and I will split it at this point, and I will select this arc and I will split it at this particular point. And now I will select all of these. I will select all of these, and I will move them to the construction layer. And so I have just randomly named this. You can organize the layers properly. Yes. So this is the final solution. That is, this is the isometric projection of the problem that we were solving. So we have solved this particular problem, and this is the isometric projection of this. And please save the files. And this the manual drawing has to be done on isometric grid sheets, and this has to be practiced in the software. So that's it. This is the complete solution. Thank you.